Welcome. So in this part of the lesson, we're going to be talking about solving combination rate problems. So let's begin by reading this question before us. It says 3 water hoses from 3 different taps are used to fill a large swimming pool. The first hose alone takes 200 hours to fill the pool. The second hose alone takes 120 hours to fill the pool. And the third hose alone takes only 50 hours to fill the pool. How long would it take to fill the pool if all 3 hoses were used? So let's just stop and reflect upon what this question is asking us. It's saying we have 3 water hoses, and then it tells us that if the first hose alone was used, it would take 200 hours to fill the pool. If the second hose was alone used, it would take 120 hours to fill the pool, and if the third hose alone was used, it would take 50 hours to fill the pool. So what we need to figure out is how long would it take to fill the pool if all 3 hoses were used. So how are we going to approach this question? The first thing that we're going to do is find the lowest common multiple of the 3 numbers that we're given, so 200, 120, and 50. So we're going to find the lowest common multiple of 200, 120, and 50. And that's going to be 600. Now, when you're doing these combination rate problems, finding the lowest common multiple is a very important skill. And I know that for many of us, doing this may seem a little intimidating. So what I'm going to do is I'm going to put a little asterisk here. And at the end of this video, I'm going to talk about a technique you could use to find the lowest common multiple. But let's keep on going. So we found the lowest common multiple of the numbers we were given. What we're now going to do is say in 600 hours, so that lowest common multiple, how many pools could hose 1 fill? So hose 1 would fill how many pools? Well, if it takes 200 hours for it to fill 1 pool, in 600 hours, it could fill 3 pools. And you can think about the maths that we're doing here. We're going 600 hours over 200 hours per pool. So that means we're going to get 3 pools. Then you'd go hose 2 would fill how many pools? Would fill, well, hose 2 was 120 hours to fill 1 pool. So that means in 600 hours, it would fill 5 pools. 5 pools. So what maths am I doing here? I'm going 600 hours over 120 hours per pool, and that's going to be 5 pools. You can think about it as 60 divided by 12. And then hose 3 would fill how many pools? Would fill, well, hose 3, 50 hours, right? So that means it's going to fill 12 pools. And that makes sense because if it takes 50 hours to fill 1 pool, then in 600 hours, it will fill 12 pools. And the maths that I'm doing here is 600 hours over 50 hours per pool. And that's going to end up being 12 pools, as we said. And you can think about it as how many times does 5 go into 60? 12 times, 12 pools. Perfect. Having now done that, the next thing that we're going to ask ourselves is, well, in 600 hours, how many pools would I fill? How many pools would I fill in total? So I've got all these hoses. In 600 hours, I'm going to fill 3 plus 5, which is 8, plus 12, which is 20. So in 600 hours, I would fill 20 pools if I was using all of the hoses. So let me repeat that. If I was using all of the hoses, in 600 hours, I would fill 20 pools because 3 plus 5 plus 12 is 20. So let's write that down. We're going to say in total, if all hoses were used, I would fill 20 pools. We could therefore figure out what the filling rate is going to be. What is my filling rate going to be? Well, I would say for 600 hours per 20 pools. And now, what are we trying to find? We're trying to find how long it would take to fill one pool. So what I'm going to do is I'm going to divide both sides by 20. And that's going to leave me with 600 hours divided by 20 will be 30 hours, and 20 divided by 20 will be one pool. And that's really my answer, isn't it? Let's give that a bit of a highlight because it's very important. And then it's always good to write what you've done in one final sentence. So let's do that. So I'm going to say, I might need to scroll down a bit here. It will take 30 hours to fill one pool using all 3 hoses. It will take 30 hours. And that is my answer. So that's how you would approach this question. Now, as I said, finding the lowest common multiple is a very important step. And some of us might be like, oof, I'm not feeling that confident with being able to do that. So let's talk about a technique that we could use to help us find the lowest common multiple. So we spoke about this all the way back when we were going through exercise 1D, and you're finding the lowest common multiple through prime factorization. So for the LCM, include all the different primes, raising the common primes to their highest power. So the first thing that I would do here is actually look at this and say, hey, I've got 200, 120, and 50. What do you notice about all of these? They all end in 0. So it's probably easier for me before I do the prime factorization just to get rid of a 0 from each of these. And then I just have to make sure I add that 0 back at the end. So it's just a little trick that we can use. Now we do our prime factorization. This will be 4 and 5 and 2 and 2. This will be 3 and 4 and 2 and 2. And this 5 is already a prime, but let me just write it as 1 and 5, just for completeness sake. So as you can see, I've got my primes for each of these. Got my primes, 1 and 5. And now what we have to do for the LCM, include all the different primes, raising the common primes to their highest power. So that means to find my lowest common multiple, what I'm going to do is I'm going to go, well, I have 1, 1, so I go 1 times. Then how many 2's do I have? Well, I have these 2 and these 2. And now I have to raise it to the highest power. Well, the most amount of 2's I have is 2, because I have 2. So the most amount of 2's I have for a number is 2. So I'm going to go 2 to the power of 2. Then what's the most amount of 3's I have? Well, I just have 1 of them. And what's the most amount of 5's I have? Well, I have 1 5 here. I have 1 5 here. The most amount of 5's I have for any number is just 1. So I times it by 5. And now I can go 1 times 2 squared is 4, times 3 times 5. 1 times 4 times 3 is 12. 12 5's is going to be 60. And then remember, I said that because we took off a 0 at the start, I have to make sure I add that 0 back at the end. So my answer will be 600. And that's what we found over here, 600. So that's a good little technique to find the lowest common multiple. It's through prime factorization. So hopefully you found this video useful. In the next video, I'll go through a very similar question. So you should give this question a go, this one down here, before you watch me go through it, and hopefully you're able to get it right. I'll see you in that next part.